Okay, now let's run the linest function and develop coefficients. Model 1 is only dx sub 2, so one column for the slope coefficient and one for y-intercept. So we need two columns here, and then we do linest function, and we're going to do difference in y as the y-axis value or y range. Okay, only the estimation sample. Then dx sub 2 is the only x range. Okay. And then comma, comma 1, close parenthesis, and do Control Shift Enter. So that will give us the output, okay, for model 1. Okay. Now let's format this. Okay, so that's the first model. So here we have d except 2 there. Okay. Model 2, so this one is for both model 1 and model 3. They both are the same. Model 2, we're going to have dx sub 1, dx sub 2, and dx sub 6. Now these are not adjacent. We have to have the columns adjacent for us to be able to run linest. So we have to go to the data and assemble them, okay, in a way that we will be able to select them in the linest function. So dx sub 1, dx sub 2, and then dx sub 6. So these are the three. Okay. So now if we copy, so that will go. So let's put borders here, and we'll copy this only for the estimation sample. We don't need that for others. So okay, there. Now let's run the linest function. So we have 3 slope coefficient variables, and then there is intercept. So we have to highlight 4 columns, and then do linest, then y range. So y range is still here. Okay. Comma. Now the x range is the newly assembled data, x sub 1, x sub 2, and x sub 6, comma, comma 1, close parenthesis, and do Control Shift Enter. Okay, so now we have the output. Okay, so we have the two alternatives. So let's apply these two model estimates to the holdout sample. So we have the holdout sample already here. So for model 1, which is here, okay, we need data for dx sub 2 only. So we have the y variable, okay. Then we need dx sub 2. Okay, so let's get dx sub 2 for the last row of the estimation sample. We start with from that, and then the rest of the way. So dx sub 2, let's first locate dx sub 2, which is in column BA. So go to start from the last row of the estimation sample. Okay, so then we can copy that down. So we have the dx sub 2 for the holdout sample. So our estimation here is the fitted value. Okay, now remember, we are using the differences. So when we apply this model, we'll get an estimate for the difference in y. Okay, so fitted value for dy sub t. So forecast for dy sub t is going to be, okay, start from here, b sub 0, which is that, absolute reference that, plus b sub 1, the slope coefficient, absolute reference that, times dx sub 2. Okay, so that's our forecast for dy sub t, okay, for January 2009. Okay, now we can copy that down. So this gives us the estimate for dy sub t. Now, what is the forecast? But what we want is a forecast for y sub t, not dy sub t. So how are we going to get that? So that's what we want. Okay. So remember, dy sub t is y sub t minus y sub t minus 1. So if we want forecast for y sub t, then you take the forecast for dy sub t and add y sub t minus 1 to it. Okay. After all, this dy sub t is our forecast for the difference between the previous period and this period. So if you take the actual value of the previous period and add to that our forecast of the difference, that will be the forecast for y sub t. So all we have to do here is to take the actual value of the previous time period and add our forecasted difference. That will be our forecast for y sub t. Okay. Now copy that rest of the way. So now we have forecast using the first model, but that is just one only one predictor variable. Okay. Now let's apply the same and find forecast for the second model.